Well, hello everyone. It's time to take a little more of a look at this Commodore 64 that we saw in the part 1 video. So where we left off was I was going to kind of do some general checking of the system and do some voltage checks and things, just to kind of make sure that everything looks good to go here. I did get some comments from the last video about this power supply, and folks did mention that yes, that is a serviceable supply. It is still something that can be worked on, and you put something in line for overvoltage and this would work just fine. So maybe I'll get back to this and kind of go through it and get this up to snuff, but this isn't what I'm going to be using today. So what I'll be using today is this aftermarket supply. It's a modern power supply with adequate overvoltage protection, and we'll use it even though I could work on the other one and get it going. We're just going to go ahead and run with this one. So where I thought I would start is I'm going to do a couple of things today just before I get going, just to eliminate some common problems. And kind of in sequence they are, I'm going to go ahead and pull the SID and just set it aside for now. I don't want anything to potentially happen to that if I do have some kind of a voltage issue here. So I may also go ahead and pull a few of the other socketed chips too. And then just kind of check the power rails, make sure that everything looks right so that I don't make anything worse than it is should this machine have issues. And we haven't even really turned this one on yet, so this is still a bit of a mystery box for us. You might remember it's a very early revision, and so I know that there are some things about this that are not going to be super, but we'll see where we're at. Most of the pin legs look fairly shiny, so that's a good thing. All right, let's take a stab at looking at a few things here. I want to check the power switch when it's in the on position here. And it looks like we have a ground side here. All right, I am going to go ahead and hook up power, and then we'll see what we see on the incoming side of this. So we have 4.962, which is good. And 12.1 AC, which I think is fine. I think that's a no load condition, so I would expect that would pull down substantially. So, all right, we'll check voltages a couple other places, and we'll pick it up here off the cassette port interface. And we're going to be looking for DC there. 4.955, that should be fine. And we should pick up AC off of here. Okay, when I was testing around on this board, I found right away that I had an issue related to no AC on the user port, the 9-volt AC that's supposed to be there. So, of course, first thing I checked was the fuse, and guess what? We had a blown fuse. So that's the first thing that we've run into, and I think that is a good place to start. So with a new fuse, we'll plug that in and kind of check around again and see what we get. Okay, that looks quite a bit better. So we're actually seeing about 12 volts AC there, but again, I kind of expect that given that there's no load on this system, so I think we'll be okay there. Now let me kind of pop around the board and check out some other voltages. Okay, we have 12 volts and 5 volts, or 4.96 on the SID socket, so that's a pretty good indicator that things are good there. Okay, we're picking up 4.96667 at the 6510 socket. So I think we're in good shape here. I'm not too worried about the voltages we're seeing on here. So I'm going to repopulate the board, and then we're going to plug it in and see what happens. All right, with everything populated but the SID, I'm going to go ahead and we're going to power this up and see what we see. Okay, moment of truth. Okay, we are picking up an NTSC signal, but it is a black screen. So, we're putting out video, but we are not seeing anything. Now, one of the things that I don't have up to this point is I don't have a dead test cartridge or a diagnostics cartridge for the 64. I do have a ROM for the 128, but I think that's something that I need to remedy. So seeing now that this is non-functional, I think it would be good to have a dead test cart. So I'm going to take a few minutes, and I do have the bits and pieces to do that. So I am going to put one of those together. Okay, I've got my two boards together. The red one's going to be my dead test. The green is going to be my regular diagnostics test. And now it is time to go ahead and burn the ROMs for these. All right, here's our broken 64. And we'll get it set up with the dead test cart because we already know that this has a black screen. Okay, right away we are getting a flash pattern. And I believe that is a code 1. According to the documentation, that code points to U12, which is this RAM chip right here. However, it really could be U12, could be U12 and other RAM chips. Could also be some of the other supporting chips on the data bus. So it really could still point to anything. But we have a likely culprit in U12. So at least we have something. We do have a flash code. At least we know that we have a working processor and we have a working VIC chip, or we wouldn't get this far. So one of the things we could do just for fun is to pull the other chips on the board that are not necessary for the dead test and then see if anything changes, just on the off chance that it isn't the RAM, but it's something else on the data or address bus that's messing things up. But I doubt it, but we can check. All right, now we're just down to the chips that are necessary to run the dead test. Let's see if we get the same result. It appears we do. So we're right back to our single flash. So we're sticking with our current diagnostics, looking at U12. And probably the best thing to do is to go ahead and pull that chip, put a socket in, and put in another RAM chip and see what happens. Okay, here's something interesting. Just for fun, I decided to put in just the straight diagnostics cartridge and see what we get there. And initially, we power up the system and we get a nice black screen. But if I go ahead and reset, we can get the diagnostics running. Now it has a pretty ugly looking screen, but it is running. So this is kind of interesting. And the other thing that's interesting is it passes its RAM test. That's sort of interesting. Wow, that looks terrible, but what's interesting is our dead test shows something with U12, but when this runs, it does not. So that's interesting. Okay, just for fun, I pulled the revision 5 VIC2 chip out and put in a revision 8. I'm not 100% certain if the revision 5 chip or revision 8 chip is in fact good. It's just something that's kind of in the parts stash. So I just wanted to switch that out and see if there was any change. No, it looks like the behavior is similar. Let's see if the reset. Although the video looks pretty much, it looks quite a bit better. So, okay, that's interesting. That's a little bit of a gain. Unfortunately, this is the VIC chip that really goes with this system date-wise. So, but it really just looks terrible. So it's interesting that the system doesn't boot at all, but when I give it a manual reset, it boots. Is that something that could have to do with the reset circuit? Is there just kind of a timing thing on boot up where, I don't know, I'm babbling. What do you think? This is really interesting. So we have a system that looks good on the diagnostic. The only thing we have to do is just give it a reset to get it running. Okay, here's the deal. So looking at this system, I just thought, you know what, I'm going to go ahead and rig up just a cartridge slot reset button. Since the reset button on the diagnostic seems to get this thing kicked into gear, I thought, well, let me go ahead and do that, because I know that doing a reset via the cartridge port completely overrides anything trying to stop the reset function. So I could do something on the user port, but I'm going to plug this in to this port and see what happens, because this is just weird. I'm starting to think there's not anything substantially wrong with this other than maybe something with a reset circuit. And so that's what I'm going to have to look into. And yep, we have a black screen. If I do a reset, ha! All right. So interesting. Okay, so I need to look at some schematics and figure out how the reset works. And we may just have an issue with that. The other thing I might do is pull the CPU and just make sure that we've got good connections in all the pins, especially the reset pin. And maybe there's no chip replacement in the future of this other than that original VIC just, it just looks awful. Okay, let's go ahead and try to capture the reset. So I am currently on the reset pin on the processor, and if we power this thing up, it immediately goes high. Then, of course, when we do a hard reset, now we get the system booting. All right, so I think we've pretty well narrowed this down to a problem with the reset circuit, or at least there is some reason why the CPU never gets a reset signal on startup. And so we were able to plug in a little cart with a reset button on it and prove out that the system is functioning. We've run the diagnostics. Everything looks good. With this revision of the motherboard, the 326-298 revision A, the reset circuitry does not match the schematics in, for example, the programmer's reference guide. When I look up the schematics for this board online, I can find them, but there's a factory bodge here that is not shown on the schematic, and there is a missing resistor, a 1K resistor in this circuit as well. And in doing a little research online, I found that a lot of people have had issues with the reset circuit on this early board, and cartridges that were plugged in that sent reset signals, multi-carts and things like that, would crash the system, cause other problems. And so a lot of people have modified this area of these boards, and I think I'm going to do the same. I don't really know that my reset problem is specifically these two chips. There's a open collector version of an inverter chip here, and then we have a 556 timer also here. And I think what I'm going to do is I'm going to pull at least the timer off and install a socket, because I'm going to make a little bit of a mod where I'm going to keep this bodge wire, but I'm going to pull up pin 9 on this chip, pull it up out of the socket so that it's not in circuit, and then I'm going to restore the 1K ohm resistor to the R36 position. This is the mod that most people use that makes these old boards more compatible with later types of cartridges or multi-carts, and I think I'll do that anyway. So while I have this out, I'll have a socket in there, and if it does happen to be the 556 that's at issue, I do have more of these, I'll plug a clean one in. And then I also wonder a little bit about the 7406. But if it turns out to not be an actual component in the reset circuitry, I guess I'm going to have to run around here on the board and find out what exactly is keeping the reset signal high all the time. Okay, so this is pretty much just with replacing the 556, and I want to see if there's any difference at all. And it does not appear so. Oh, behavior is still the same. So we have a new 556, and we're still getting no reset. So I am going to go ahead and do the 7406 and check then and see what's going on. And if not that, then we have a lot more searching to do. Okay. All right, well, the experiment on the ICs and replacing those ICs that are part of the reset circuit does not seem to have done as expected, which hopefully was going to be to correct the problem, but doesn't appear so. One of the things that I'm going to do is I am going to just quickly do the mod that's talked about a lot for this particular board and see, but I think that this should still reset on its own, even without that modification. I mean, they did sell this model, and I'm sure that all of them weren't having this issue. So part of the mod is to pick up pin 9 out of the socket. So I'm just going to kind of straighten that one outward and put it back in, and then to install the resistor that's shown on all of the diagrams or the schematics. And that would be R36, and that would be a 1 k ohm resistor. And this is a mod that I'll leave in place even if this does not correct our problem and we have to search elsewhere, because this will be beneficial in the future for this machine, so that its cartridge port is a little bit more useful with special carts that need to be able to reset the system. Yep, we're in the same state. Okay, I did go ahead and pull the cap out of there that's being used on the 556, at least one of them. Doesn't measure anything near what it's supposed to be, so I'm going to go ahead and replace that. That's one of two that are in the circuit, but let's just try it at this point and see what happens. That was it. Okay. Okay, what have I learned from this? So what it turned out to be, I did go ahead and replace that one capacitor in the timing circuit. When I pulled this little guy out, he measured just literally like 0.009 or whatever picofarads. It's supposed to be a 10 microfarad cap. So I replaced that, and lo and behold, that fixed our issue. So I'm reassembling this. Some of you are going to say, why are you putting that heat shield back, or the RF shield back on this? And again, just authenticity. I'm just kind of putting this thing back together the way that it was, and that's what I plan to do. Keep it as authentic as possible. I've replaced the original chips back in the sockets I installed. I did leave my mod in place for the reset circuit, but other than that, we've got a pretty much authentic, original 326 298 board with all of its flaws, with its crummy VIC-2 chip and terrible image quality and all of the flaws and bodges contained therein on this board. So. Okay, everything's back together, and yeah, not cleaned up yet, but that's something that can wait. This thing's a little kind of on the brown side, so maybe in the nice summer sun I'll get a chance to sun-bright this or retro-bright it a little bit and get that looking good again. But let's go ahead and run our final diagnostic. And again, I do apologize for how bad this looks. This is not just my video capture. This VIC-2 chip in this is really this bad. It looks a little better in the normal boot with the light blue on dark blue. It's not quite so bad, but yeah, this is this is just hideous. Between my cheap HDMI converter and the condition of this VIC-2 chip itself, doesn't look super great. There we go. I guess I can check them out a little more, and I can boot a game cartridge in this and see what happens. And I think maybe I will do that. I don't promise to be any good at this, so you're not going to judge my game playing skills here. Oh, I am terrible at this. I used to play this back in the day at the arcade, and with that system it was much better, but yeah, there I've lost. And something you can really see here is just how terrible that VIC-2 chip is. So if I were actually going to be using this system, that for sure would have to be changed out for a newer revision. And I do have a few of those around here. But I think while this is just stored, I have other Commodore 64s that I will be using kind of more as my daily drivers. And this is just kind of a neat example of an early system. So I think I'll keep it the way it is. For the most part, it works. Our black screen is gone. And at the end of the day, it all turned out to be this. With that, it's time to pack this Commodore 64 back in its box, and until next time, thanks for watching.